This conference will now be recorded.
We were discussing about what is stateful set and how it works, how to create a Mongo database cluster in Kubernetes as a pod containers. We discussed that and how it was working also we discussed. Today, I thought of discussing about resource quota, limit range and network policies. But before I go that, let's try to discuss about scheduling concept. I'll discuss that resource quota and limit range network policies later. First, discuss about scheduling. How scheduling is happening in Kubernetes. As I already told, by default, how scheduling is happening, we know we discussed many times. By default, how scheduling is happening in Kubernetes, I mean to say, how parts are getting scheduled in Kubernetes. What is the default scheduling behavior? Anyone? What is the default scheduling behavior? We discussed a lot of times. Anyone? How parts are getting scheduled by default? How Kubernetes is deciding in which node that parts has to be scheduled? What is the default scheduling behavior? Scheduler will schedule, but how? What is the default scheduling? Scheduler will schedule the pods to the nodes. Scheduler will decide in which node that pod gets scheduled. In which node that pod will be scheduled will be decided by scheduler only. But what is the default scheduling behavior? On what basis scheduler is deciding? That is what my question. The scheduler is deciding based on the resources available on the nodes, comparing with resources the pods are getting requested. Based on the resources pods are getting requested and based on the resources actually available in that node, it is deciding. We discussed a lot of times, but still people are very they're not confident to answer. So that is the default scheduling behavior. So the default scheduling behavior will work for most of the cases. For most of the scenarios, the default scheduling behavior will work. But let's say I have a special use case, special requirement. I want my parts to be scheduled on the specific nodes, or I don't want my parts to be scheduled on some nodes. I want my parts to be scheduled on group of nodes. So if you have those type of use cases, is it possible for me to control how parts get scheduled by the scheduler? Will I able to control the scheduling part if I have those type of requirements? Yes, that is possible using some concepts. That is possible using some concepts here. So Kubernetes scheduler ensures that right node is selected by checking the node capacity, of CPU and RAM and comparing it to the pod resource request. The scheduler will make sure that each of these resource type, comma, sum of all the resource requests by the pod containers which is already running on that node, even after calculating, it will try to sum all the resource request by whatever pods which is already requested and running in that node. It will try to minus that one from the node capacity, and if we still have some CPU and memory, and if that is matching with the other pod resource request, that pod gets scheduled in that node. So this mechanism will ensure that the pod will end up in the right node with spare resources. So this is the default behavior. The schedulers, the Kubernetes scheduler default behavior works well for most of the cases. So it will ensure that parts are only placed on the nodes that have enough CPU and memory. It will have enough CPU and memory. It will try to balance out the resource utilization of the nodes. This is the default behavior. It works well for the most of the cases. But however, in some scenarios, you want your parts to be scheduled in the specific nodes. In some scenario, you want your parts to be scheduled in some specific node. You want your parts to be end up on a machine with a whatever machine which has a SSD storage or some special type of server. I have some servers with SSD storage attached, or I have some server with high CPU optimized servers I have. I want my parts to be scheduled only in that node where I have a special type of hardware, special type of machine. You want your parts to be end up on that machine, or you don't want some parts running in the same machine. You don't want some parts to be running in the same machine. Two parts don't want to run in the same machine. You want those two parts to be distributed to different machines. You have this type of requirement. Or you want to run some parts together in the same node. You want to co-locate the parts on a particular node. Same node, you want two applications, two different application parts to schedule on the same node. You have these type of requirements. Then you have to use some concept, scheduling concepts in Kubernetes. We have some concepts like simple one, node selector. Another one is node affinity. Another one is pod affinity, anti-affinity, pod anti-affinity, pod affinity, pod anti-affinity. And we have taints and tolerations concept. And also we have a cordon, uncordon, and a drain. So you have some kind of a scheduling features. These are some kind of a scheduling concept. Using these concepts, I can control how my parts can get scheduled to my Kubernetes nodes. Now the first one, the very basic one and simple one is node selector. What do you mean by node selector? Now, node selector, simple part scheduling feature that will allow you to schedule a pod onto a specific node where the node labels are matching with node selector, where the node labels are matching with node selector. Now, I have a Kubernetes cluster, let's say. I have a Kubernetes cluster, let's say. Can I add a labels to the nodes? Can I add a labels to the nodes? Now let's consider these are my nodes, my Kubernetes nodes. That can be a master node, that can be a worker node, whatever it is. I have some nodes, I have some servers. Is it possible for me to add a labels to the nodes? The way we are adding labels to the pods and other stuff, is it possible for me to add a labels to the nodes also? This is one node, this is another node. Is it possible for me to add labels to the nodes? This is another node. This can be a master node. This can be a master node, or this can be a worker node. These are like worker nodes. Now, I can add a labels. I can add a labels to the nodes. Let's say this node. I can add a label, any key value pairs. Labels are key value pairs. Can I add a label like this? Name, something like this, or can I add a label? Whatever. Just key value pairs. Can I add any labels, n number of labels to the nodes like this? I can add a labels like this. While creating a pod, in my pod manifest, can I use something called node selector? something called node selector in my pod manifest, can I use something called node selector? If I use node selector like this, now I am requesting with this option in my pod manifest, request goes to the master, request goes to the master. Now the scheduler will, I try to see this guy is using something called node selector, and the scheduler will try to schedule that pod to the node where that selectors are matching with that node labels. Does that scheduler will try to schedule that pod to that node where it is matching, wherever it is matching that select that labels? Yes. Same concept we used in the Docker Swarm. Did we use that labels and constraints concept in the Docker Swarm? Did we use that labels and constraints concept in the Docker Swarm? Similarly, here a node selector. Now, if you see, let me connect to my Kubernetes cluster. Let me connect to my Kubernetes cluster. Let me connect to this machine. Let me connect to this machine. First, make sure I have my nodes ready. Make sure I have my nodes are ready. My nodes are running. There is no issues in my nodes. Now, if you see, if I want to describe, I can describe the node also. If you describe the node, you can see the labels also. Lot of details are there. Whether that node is healthy, what is happening in that node, is it running out of memory, is it having a disk pressure, is kubelet down, or all those things you can see. And if you see, I already do have some labels, default labels attached already. Some labels are already attached to that nodes. But who added all these labels? Who added all these labels? When these labels got added by default, these got added whenever we initiated the cluster, whenever we joined that machines to the cluster, these labels got added. These are the default labels. Now you observe any node, there are some labels. I am describing this node. Can I see some labels already? Some labels. These are the default labels. If required, can I add my own labels also? If required, can I add my own labels also? If required, we can add our own labels. And can I use those labels in my pod manifest as a node selector so that scheduler will try to place that pod in whatever node that labels are matching with your selectors? Yes, it will try to schedule the pods to the nodes wherever that labels are matching with your node selectors. Now, if I want to see only labels without describe also, do I have some option like kubectl get nodes hyphen show hyphen labels? Can I use this sub commands? Now, if I execute this kubectl get nodes hyphen show hyphen labels, is it showing the labels? I'm just reducing the font size. So is it showing the labels whatever we have on that node? If I execute like this, so now these are the default labels. These are the default labels whatever I have by default. Now, if I want to add a label, can I add something like this kubectl label add command? There is a command called label add like this. Label what you want to label. Kubectl label what I want to label. Which Kubernetes object I want to label. I want to label a nodes. Node. Can I use node ID or name? Whatever I am getting here. Can I use this node ID or name this one or this one? Which node you want to label? Can I use that here? Like this, the node name, I can use which node I want to add a label. Can I use any key, any value, whatever I want to add? this label key label value. Yes, I can use something like this. Don't copy paste as is. Don't copy paste as is. This ID may change. So I'm typing something like this: kubectl label nodes. Now let's say I want to add a label to this node 206. I want to add a label to this node 206. Can I give anything? Something like this: name worker1, like this. If required, multiple labels also, storage. Suppose the server has a SSD disk, something like this. Based on your requirement, based on your identification, can you add any labels like this? Multiple labels also like this with space separated at the same time. Yes. Now let me add one label. Now when I get the labels, now can I see that label added to that node, the 206 node? Can I see that label, whatever just now I added? Now in my pod manifest, can I use this as a node selector? In my pod manifest, can I use this as a node selector? Whether you are creating a pod directly, whether you are creating a deployment, whether you are creating a replica set, whether you are creating a daemon set, stateful set, can I use that? Because that comes under pod spec. That comes under pod spec. So can I use that node selector? Whether I am creating a pod directly, whether I am creating a deployment, replica set, stateful set, daemon set, that doesn't matter. Can I use that node selector concept to schedule my pods into specific nodes? Yes, yes, you can use in any type of Kubernetes object like deployment, stateful set, replica set, daemon set, all those things. Something like this in your specification. Now, can I directly use in pod also? Because sometimes you get these type of questions in CKA or CKAD exam also, guys. In CKA and CKAD exams, it is a scenario based questions. As I told multiple times, it is not like a multiple choice question. It is a scenario based question. They may ask you to create a so and so pod using so and so image in so and so node. In that case, do you need to be familiar with all these concepts and with a lot of practice and hands on to do that quickly? Yes. So here you can use that for pod, you can use that for deployment based on your requirement. Now we added a label like node selector. There is a concept called node selector. It is the simplest scheduling feature which we can use to schedule your pods based on the labels you added to the node. Then you can assign the pods to that node. I can add a label like this. I can add a label like this. Then can I use that like this? Whether I am creating a pod here, whether I am creating a deployment, replica set, daemon set, that doesn't matter here. Can I use this here? Because it is coming under your pod specification. Can I use that node selector for any Kubernetes object? Yes. Now, let me show that. As of now, I don't have anything in default namespace. Let's see if I have something in test namespace. I'll delete and demonstrate. As of now, did I use any concept called node selector for any applications, any pods, whatever we deployed so far? No. But is it mandatory to use all these things? Is it mandatory to use all these things? Node selector, node affinity, pod affinity? No. That is based on your requirement, based on your use case, your requirement you need to use. Since Balaji sir is explaining, since he is giving running nodes, then use this. Don't do like that. If you have a requirement, then only you need to use that concept. Otherwise, no. Now, first I'll delete all these applications. You may have a question, sir, why you are deleting all these things? If I try to schedule lot of applications because of resources, it will not work. It will go to a pending state. So I don't want all that to be happen. So I'm deleting all Kubernetes objects, whatever have in this namespace, so that I'll get some space. But in actual applications, live environment, to deploy your application, are you going to delete other applications? No. Very big no. Okay. Now, I don't have anything. Now, I added a label. Now, let me take any application. That can be any application. That doesn't matter here. Now, let's consider maybe this application. I am creating a deployment and I am not given any replicas also. How many replicas it will create? By default, 1. Now, if I want more replicas, I need to give that replica. I need to give more replicas. Then I have to give something like this, replicas as 2 or 1 like that. Now, here I am not using any node selector concept. Based on the resources which I am requesting, based on the resources are available in the nodes, the scheduler will assign in which node that parts can be scheduled. Yes. Now, if I want these parts to be scheduled in a specific node, can I use that concept here? Node selector. Node selector. Now, that node selector, whatever label you have given, whatever label you have given, what label I have given, like worker1, name worker1. Now, can I use that name something like this, name like this? Now I am intentionally doing some mistake here. I am intentionally doing some mistake here. Now these are case sensitive. These are case sensitive. When I am adding a label worker1 O caps, but here I am giving worker1 O small. Now the scheduler will be able to find any node with this key and value as a labels on the nodes. Then does your scheduler will try to schedule this pod? Does this will work? No. Now let me show that. kubectl apply -f, that Java web app I am deploying. In which namespace? Let's see. I think since I have not mentioned that in an, oh sorry, I am executing delete. Okay. So since I have not mentioned any namespace in that YML, I think it is deployed in default namespace. But if you see, what is the status now? That pod status pending. Why it is pending? What could be the reason? How to troubleshoot? Debugging and troubleshooting also important. kubectl describe what I want to describe. What I want to describe? I want to describe a pod. This pod. Now what it is saying? The scheduler is trying to say something. It is informing you something. What it is saying? Take a screenshot and send it to Balaji sir. It is saying something like this. Take a screenshot and send it to Balaji sir. He will explain. It is saying something like that. So it is saying 0 by 3 nodes are available. It is saying total 3 nodes are there. 0 by 3 nodes are available. Understanding, reading the error message is very, very important. I told multiple times. Understanding the error messages, reading the error messages is very, very important. Because you are going to get different types of issues. We are, like I mean to say, we are available to solve the problems. Because companies are hiring you to solve some challenges, some problems. So you are going to get definitely lot of issues. But do you need to be good at understanding, troubleshooting, reading, doing some fixes? That's why they are hiring you. Now, if you understand the error message, read the error message, any error message, at least is it going to give something kind of 60% of the solution? I mean to say, not the solution, it is going to give what exactly the problem. Based on the problem, will you be able to identify and rectify that problem or fix that problem, any problem. So now if you see what it is saying, 0 by 3 nodes are available. One node has a taint. It is saying one node has a taint. One node has taint. Our pod is not tolerating that. The master node. Do we have a taint on the master node? Am I tolerating the taint in my pod manifest as of now? Am I tolerating the taint in the pod manifest as of now? No. So because of that, is it allowing to schedule in the master? Is the pod, whatever pod I am trying to schedule, is it allowed to be scheduled in the master? No. What about other two nodes? What about other two nodes? What it is saying? What it is saying? Two nodes did not match node affinity or node selector. Node affinity or node selector, it is not matching. Because I use this node selector. I use this as a node selector, name worker1. If you see, do I have any pods with that label? kubectl get nodes. Do I see any nodes? Do I see any nodes with that label? You may have a question, sir. We have here, right? You have here. In this node, we have that label. But why? Key is same, value also same, but it is case sensitive. It is case sensitive. Worker1. I had a label O caps worker1. When I am using selector O small. So because of that, it is not working. Now, there are two chances here. There are two fixes here. One, can I update my label of the node or can I update the selector of my pod? Anyone. Either I can update the label of my node or either I can update the selector of my pod. Anyone I can do that. Now let me update the selector here. Since it's a deployment, I am making the changes in my pod spec. Then if I apply again, now this time you see these pods got scheduled now. Now if you see why it is scheduled in same node, why it is scheduled in same node, both pods are scheduled in same node, why it is not scheduled in another node, different node, why both replicas are running in the same node? Because of the selectors. Do I have other node with that label? Suppose if I have other nodes also with that labels, does my pods will be distributed between those nodes wherever I have same labels? Does my pods get distributed to those nodes wherever I have same label? Yes. Now if I try to scale also, now, let's say whether I am scaling manually or I am using these commands to scale. Now let's say I am trying to scale maybe 3 replicas. Again, I am trying to apply, whether it's a auto scaling HPA, whether it's a manual scaling, that doesn't matter. Now in the same node it is trying to come up. Why this time it is pending? Why this time it is pending? What could be the reason this time? Now you read the error message. 0 by 3 nodes are available. One node has a insufficient memory. One node has a insufficient memory, and one node has a taint. Our pod is not tolerating, and other node is not matching with selectors. Other node is not matching with selectors. Other node is not matching with selector. One node is not tolerating the taint, and one node insufficient memory. Because I have less CPU, is it able to schedule in that node wherever it is matching also? Is it able to schedule because of no resources available, no CPU, no memory? No. Now, because of this node selector, Let's say if I try to add a node selector, same label to other nodes also now, does this part can go to that node? If I add a same label to some other nodes also, it will work. So this is the default scheduling. Now, if something goes wrong with that node, what will happen to these pods, guys? Let's say something went wrong with this node. That node went down because of insufficient CPU or disk pressure, memory pressure, kubernetes failed in that node. If that node went down, what will happen to the pods? These pods, Krishna Prasad is saying it will reschedule to other nodes. But unless until other nodes has that label, does that pods get rescheduled to other node? No. So it will not get rescheduled to other nodes unless until they are matching labels. So in real time, are you going to at least use the same labels for group of servers? Because you are not going to uniquely label the nodes. You will have these type of problems. So instead of having a single server with one label, can I have some 2-3 servers with same labels and selectors with different hardware or storage like that, so that it will get scheduled only in that group of servers? Yes. This is simple selector, a scheduling feature called node selector. Is everyone clear? What do you mean by node selector? How it will work? Now, this is simple basic scheduling feature. Now we have some advanced features also. Kubernetes offers some advanced features. Kubernetes also offers some advanced scheduling features called node affinity. What do you mean by this node affinity? So node affinity is advanced version of node scheduling. As we already mentioned earlier, node selector is the simplest part scheduling feature, in Kubernetes. This affinity, this node affinity will expand the node selector functionality with a lot of improvements, kind of advanced version of node selector. Now, this affinity language is more expressive. It is more expressive. What do you mean by more expressive? Can I use more logical operators if I use node affinity comparing with node selector? Can I use more logical operators like in, not in, like that expressions when I am using node affinity? Yes. When I am using node selector, is it kind of a equality based selector here? Is it kind of a equality based selector here? Am I able to use more logical operators, expressions like in, not in, those type of conditions here when I use node selector? No. So when it comes to node affinity, it will expand the features of node selector with a lot of improvements. It is more expressive. I can use more logical operators to control how pods are scheduled. But again, is this node affinity also works based on the labels on the node? Again, is this node affinity also works based on the labels on the node? The way the node selector is also working based on the labels on the node, is this node affinity also works based on the labels on the node? Yes, this node affinity also works based on the labels on the nodes only, but can I use more logical operations, conditions, operators like in, not in, multiple values? And again, there are soft scheduling rules, there are hard scheduling rules, which I can use in the node affinity. Soft scheduling rules, or I can use hard scheduling rules also when I am using node affinity. What do you mean by soft? What do you mean by hard? I will explain now. That node selector is like a hard rule. If none of the node has that matching label, is your parts are getting scheduled when I am using node selector? If none of the nodes has that matching labels, is your parts are getting scheduled if I am using node selector? No. Kind of a hard rule. But when I use node affinity, can I use a soft rule as well as hard rule also if required? What do you mean by soft rule? Even though none of the nodes has that matching label which you are using in the node affinity, the still parts can get scheduled in any node in the cluster. Yes. If I use a soft rules with the node affinity, let's consider I am using node affinity instead of node selector. I am using node affinity here. Instead of node selector, I am using node affinity, but it is not exactly same like this. I will explain. Excuse me, guys. 1 second. Okay, I'll continue. Let's say I'm using node affinity here, even though I am using something like this and none of the nodes are matching. Then still, does my part get scheduled? Maybe in this node or other node based on the resources available. Even though I am using node affinity, if I am using node affinity with soft rules, if none of the nodes are having that label which I am using here, does my parts get scheduled? Maybe in this node or this node or this node based on the resources available? Yes. But is that the case when I am using node selector? If none of the nodes are matching, is it working like that? No. We have a soft rules, we have a hard rules. In the node affinity, we have a soft rules. We call it as a preferred rules. We call it as a preferred rules. I am preferring that one, but if it is not able to schedule because of no matching nodes, it will try to schedule in any node. Preferred. This hard rule is kind of a required rule. Hard rule is like a required rule. So it should be there. Required rules, preferred rules, and required rules, are soft rules, are hard rules. Now there are some options here. There are some options here. One is prefer during scheduling, ignore during execution. This one. This is a soft rule. Prefer during scheduling, ignore during execution. This hard rule, required during scheduling, ignore during execution. Required during scheduling, ignore during execution. But they announced one more thing, required during scheduling and required during execution also, but they have not released that feature. Whatever feature I am highlighted here, another feature, they have not yet released. They announced, but they have not released that feature. Required during scheduling and required during execution, they have announced, but they have not released. So what do you mean by required during scheduling and required during execution also? It is hard rule. Now let's say if I am using that required during scheduling and required during execution, but that is not implemented, it will not work. But just I am trying to say how it works. Is that labels has to be matched while scheduling that pod? Whatever I am using, that node affinity, required during scheduling, required during execution, is that rules has to be matched while scheduling? Yes. Then only it will schedule. Even though after scheduling, does those labels should be there on that node to continue that pod in the same node? Yes. If I remove those labels, after some time, if I use this one, required during scheduling and required during execution also, pod is scheduled, but later I remove the labels. Do you think that does that pod will sit on that node? Do you think does that pod will sit on that node? No. But they have announced that feature. But they have not released that feature. So you cannot use that one, required during scheduling and required during execution. You cannot use. But this can I use? Required during scheduling, ignore during execution. Can I use this one? The first one, required during scheduling and ignore during execution? Yes. This you can use. So as of now, this is the only preferred rule. This is the only required rule. Now, what do you mean by this preferred rule? That is preferred during scheduling and ignored during execution. It is kind of a soft rule. It is kind of a soft rule. Is it going to prefer if there is any matching node where labels are matching? Is it going to prefer that node if there is any node with matching labels? Yes. It will prefer to schedule in that node if there are any matching labels, matching nodes. But if it is not matching, is it going to ignore and schedule the pod in whatever node where you have enough CPU, enough memory? Yes. That is soft rule. That is soft rule. Now, if I am using this one, required during scheduling and ignored during execution, it is kind of a hard rule. If none of the nodes has that matching labels, which I am using in this rule, does that pod get scheduled in that any node in the cluster? No. It has to be there while scheduling. While scheduling, it has to be there. But once it is scheduled, if I remove that label from this node, is there any impact on this pod which is already scheduled in that node? If I remove that label, is there any impact on that pod? If I remove that label, no. It will not impact on that node. But somehow you deleted this pod. Somehow you deleted that pod completely. Then again will it schedule? Because you already removed that label. Again will it schedule? No. So that is hard rule. So which means you need to have that condition satisfied during scheduling. So this is two types of rules. Is everyone clear? What is this node affinity? What is preferred rule or soft rule? Or what do you mean by this hard rule or required rule? How it works? Is everyone clear? Theoretically. Now let me demonstrate with preferred rule first. Let me demonstrate with preferred rule first. Now I will delete that deployment completely. I'll delete the deployment completely. I'm going to demonstrate again. I'm going to demonstrate again using that node affinity preferred rule. Node affinity preferred. Now let me change. Now here, instead of using node selector like this, can I use advanced version of this node selector called node affinity? Something like this. Here you have affinity. You have affinity. First, you need to use affinity. You need to use affinity. This affinity. Within that affinity, what you need to use? Node affinity. Within that, you need to use something like this node affinity. Affinity, node affinity. Then under this node affinity, something different like this. Now I am demonstrate this preferred during scheduling, ignore during execution. I am using this type of rule. Kind of a what type of rule is this? Affinity, node affinity. This one, what type of rule is this? Can I consider this as a soft rule, preferred rule? Kind of a soft rule, preferred rule, yes. Under this, you need to use some options. You need to use some options like this. I will explain what is what in some time. I will explain what is what in some time. I am using like this, but indentation should be proper. Indentation should be proper. Now, this one, preference, match expressions. Now, is it more expressive? Am I using kind of a expressive, I mean to say expressions, more logical conditions here using this? Now here, can I match with multiple values also? It is like in either that can be worker one, that can be like this also, worker one, or that can be worker like this. Can I use multiple conditions also, like multiple values, same key? Can I use like this also? Yes. Now I'll remove this one. I'll remove this one. I can map with multiple values like this. Here in the operator section, can I use in, not in? Not in the sense, except this one anywhere is fine. In whatever node where I have this label key and label value, except that node, any node is fine. Can I use not in condition instead of in condition if you have that type of requirement also? Yes. Now, what do you mean by this wait? What do you mean by this wait? Now, this is preferred rule. This is preferred rule, not a required rule. Suppose this condition is not satisfied on the any node. This condition is not satisfied on any node. Still, does it has to schedule the pods? Does still your Kubernetes has to schedule the pods because we are using preferred rule? So how it will schedule? Again, it will use some kind of a weights. It is going to use some kind of a weight mechanism. Each and every node will have some weights. How the weight will be calculated? Based on the resources available. Based on the resources available in that node, it will calculate some kind of a weight. And whatever node weight is near to this weight, whatever I am mentioning, is it going to prefer in that node? Weights are calculated based on the resources available in that node, and whatever weight is near to this weight I am using here, is it going to schedule in that node? Yes. Some kind of algorithm will happen. Some kind of algorithm will happen. Weight in node affinity. So if you open this official document itself, you can understand what do you mean by that weight. What do you mean by that weight? So node affinity weight. You can specify weight between what numbers I can maintain that, what numbers I can mention that weight, 1 to 100, and each instance of this type, when scheduler finds nodes that meet all other scheduling requirements, like a lot of nodes are matching with resource request and all those things, then scheduler will iterate through every preferred rule that node satisfies and adds the value of the weight for that expression to a sum. So it will calculate some kind of algorithm, and whatever node is near to that weight, the final sum is added to the score. Then whatever node has nearby weight, then that parts get scheduled when lot of nodes are matching with all the requirements. So there kind of some algorithm will happen in the background. So that is only applicable, that only applicable when we are using which rule? When we are using which rule? That weight is applicable, that we need to define the weight only when I am using this one, preferred rule. On what basis the weights will be measured? As I already told here, what basis weights will be measured? The scheduler will iterate through every rule that node is satisfying, and it will add the value to the weight. I mean to say, based on the CPU also matching, memory also matching, and network related number of parts which is running in that, it will calculate some number, and it will try to schedule in whatever node which is matching that one. But most of the cases we will always mention values as only one value, this weight value as only one. But some in the background, Kubernetes will run some algorithm. It will try to calculate the weight of the node based on all the conditions, whatever is satisfied on that node, then it will decide. This is only for preferred rule. Most of the cases, the number will be one only. Now, even though is this condition is satisfied now, do I have any node with this label as a key? Key is matching. Key is matching, but do I have a value? This value, is it matching now in any node? But still, is my pod get scheduled in some node? Because I am using which rule? Preferred. Now let me deploy. Let me deploy kubectl apply -f. Let me deploy. Now if you see, is my pods are running? I think in my YML I have kept 3 pods. In my YML I kept 3 pods. So since it is not matching also, is it scheduled in 206? One pod is running in 93, another pod is running in 20, another 206 again, because it's a preferred rule. Now instead of preferred rule, if I use required rule, do you think will it work like that? Now I am trying to duplicate this one. File. I am using required. Now if I let me edit this. Now instead of preferred rule, now can I use required rule here? Something like this, required rule. When I am using required rule, it is little different. Required rule. So do you have that weights concept here when I am using required rule? No, there is no weights concept. When I am using this required rule, weights are not there. I'll remove that weights. I removed that weight. Now here I am using node selector terms. I am using something called a node selector terms. Under this, I am using something called node selector terms. Under that node selector terms, what do I have? Under that node selector terms, I have this match expressions. As an array. Let me match expressions, something like this. Node selector terms, under that match expressions, key operator values. So key operator values like this. Now it is required rule, but I am using wrong value. Now if I try to deploy, now to understand this better, you delete this and apply. To understand this better, you delete and apply. Even though I don't delete also, since I'm using a deployment, is it going to create those things as per the changes whatever I have done? Even though I don't delete, is your pods get created based on the changes I have done in my deployment? Yes. But what type of deployment strategy by default it is going to follow? Rolling update. But already those nodes have lot of pods running. Will it able to create a new pod before it is going to terminate old pod? It has to create a new pod. That new pod has to be in ready state, then only it can delete old pod. But if that node doesn't have enough CPU and memory, are you going to get a new pods? No. So that is different concept. You need to understand all these things. Now for better understanding, can I delete this existing deployment and again deploy, so that you will not have enough pods running in that node? You can understand properly. So let me delete that. Whatever I deployed, I'll delete. So nothing I have. Now I'll try to apply using this required rule. I'll apply this using required rule. You no need to delete, but if you don't have spare enough resources, it will not work again. Otherwise, you can change your deployment strategy. In this file, you change your deployment strategy as recreate. So first, is it going to delete old pods? If I change my deployment strategy as recreate, it will delete the old pods, then it will schedule the new pods. That way also you can do whatever. Since I am using required rule, now do you see my pods are in pending state? Why it is in pending state now? Let's describe one by one. Do you have this problem? Again, same problem. 0 by 3 nodes are available. One node has a taint. One node has a taint, other node, two nodes doesn't match with pod node affinity. It is not matching with node affinity rule. Because what type of rule I am using? Node affinity rule. I am using required rules, hard rule. Now let me modify that YML. Let me correct this one. Now I am fixing that problem. Now if I apply, now will it work? Now let me apply this file again. Now if you see, now is your pods are getting scheduled. Since I am using deployment, default deployment strategy, one pod is scheduled, it is terminating other pod. Once this is running, it is terminating other pods like that. It is terminating. But now, why this is in pending state? This one is in pending state. This one, I mean to say this one. Why it is still in pending state? This is the new pod. It has to terminate the old pod. It has to terminate this old pod. It has to create this new pod. Why this new pod is still in pending state? Because do you have enough CPU, enough memory? For this one, I am trying to create 3 replicas in the same node. Do you have enough CPU for this pod? kubectl describe. You describe this pod. You describe this pod. It is because of low resources. It is because of low resources. Now, why still it is not terminating this old pod? One more old pod is still in pending. That was pending because of no condition. That is pending because condition is not satisfied. But why it is not able to terminate this one? Because it is following rolling update deployment strategy. Unless until this becomes ready, does this old pod gets terminated? This old pod is not going to be terminated. But why this pod was in pending state last time? Is it because of low resources this pod was pending in the last time? No. It was because of that condition. To understand these concepts clear, you delete the deployments and deploy so that you can easily understand. But is everyone clear? What do you mean by this node affinity hard rule, how it works? Is everyone clear what is this node affinity hard rule, soft rule, how it works? Now let's consider one more advanced scheduling feature, pod affinity and pod anti-affinity. We have a node affinity. Similarly, we have a pod affinity and anti-affinity also in the pod. So how different it is from node affinities? Guys, as of now, this node selector and the node affinity works based on what? This node affinity works based on what? It will work based on the labels on the nodes. Based on the labels on the nodes. Everything works based on the labels and selectors only. In Kubernetes, most of the things works based on the labels and selectors only, but this works based on the labels on the this node selector and node affinity works based on the labels on what? Labels on the nodes. Based on the labels on the nodes. Now there is another concept called pod affinity. Pod affinity, pod anti-affinity. But if I use this pod affinity, pod anti-affinity, this works based on what? This pod affinity, pod anti-affinity works based on the labels on the pods which are already running in, which are already scheduled in the nodes. So this pod affinity and pod anti-affinity works based on the labels on the pods, which are already running in the nodes, which are already scheduled in your nodes. What do you mean by this one? Now I have some application. Let's consider I have some application. Let's say I have some microservice A. Microservice A. One application I have. I deployed that microservice in my cluster. Pods are running for that microservice. I'm not sure. Wherever it is, that doesn't matter. Now I have one application. Let's say application A. Application A or microservice A. That pod is scheduled in this Kubernetes cluster. Now that pod might be in this node or this node or this node, I don't know. Now while creating a pod, did we add a labels to the pod? Let's say I have added a labels for my pod like this: labels, app, Java, web app, like this. Now my pod is running here or here or here. That doesn't, but I'm not sure where it is running. Now I am trying to deploy another application, that is another application B. Now my requirement is this application B, this microservice pod should get scheduled wherever this pod is running, wherever other application pod is running. This pod is already running in my cluster. I am trying to create a one more pod, other application pod. That pod should get scheduled along with this pod. I need to co-locate these pods. If this is running, this application is running, that pod is running in this node, I want this also to go and sit in that node. If that pod is running in this node, this application, I want this pod also go and sit here. So here, if I have this type of requirement, what concept I can use? Can I use pod affinity rules? Pod affinity rules. Pod affinity rules. So if I use pod affinity, is my pods get scheduled based on the labels of the existing pods? Wherever the pod is running in that node, this pod also gets scheduled. That is pod affinity. What do you mean by anti-affinity? What do you mean by anti-affinity? Affinity you understood. What do you mean by anti-affinity? I don't want these two run together, opposite. Run two together. Let's consider I have this application microservice A running in this node. I don't want other microservice running in this node, other pod running in this node. Can I use anti-affinity rule, pod anti-affinity rules instead of affinity rules? So these are possible using anti-affinity rules. Now let me demonstrate. Let me demonstrate. So to make things simple, guys, I am taking only one pod. I am taking only one replica. Now I will demonstrate pod affinity. Guys, in this pod affinity also, do I have a soft rule and hard rule again? This pod affinity and pod anti-affinity again, do I have a soft rule and hard rule again here? The way we have a soft rule and hard rules in the node affinity, do I have a soft rules and hard rules in the pod affinity and anti-affinity? Yes. Now, node affinity, as I already explained, node affinity allow you to schedule a pod on the set of nodes based on the labels on the nodes. That node affinity works based on the labels on the nodes. That node affinity works based on the labels present on the nodes. But however, in certain scenarios, we might want to schedule certain parts together, or we might want to make sure that certain parts are never scheduled together. Then can I achieve this by using pod affinity or pod anti-affinity respectively? We call it as interpod affinity and anti-affinity. Interpod affinity or anti-affinity, we call this. We can use this one. Here, This pod affinity or anti-affinity will allow your pods to be scheduled based on what? Based on what? This pod affinity, anti-affinity works based on the labels on the pods that are already running on the node. That are already running on the node. Rather than based on the labels on the nodes, it is going to work based on the labels on the pods. Similar to node affinity, can I use this required during scheduling, ignore during execution, prefer during scheduling, ignore during execution, soft rules and hard rules in pod affinity, pod anti-affinity also? Yes, that is possible. So when you are scheduling your workloads, workloads are nothing but your applications. We may need to schedule certain set of pods together. Pod affinity makes sense. When you are scheduling some workloads, when you need to make sure that certain pods are not scheduled together, pod anti-affinity makes sense. Now here, when I am using affinity, instead of node affinity, what I am using here? Pod affinity. Here, can I use this required rule or preferred rule also? Required rule also you can use, that is hard rule, preferred rule. Now here we are using one more concept called a topology key. The topology key is like a key. Unique key you have on the label. Unique key you have on the node. But 100% most of the cases, do we have a host name unique for each and every node? Do you have a host name unique for each and every node? That host name will be unique for each and every node? Yes. So can I use that host name? Can I use that host name kubernetes.io/host name as a topology key, some kind of a unique key for each and every node we have in the cluster? Yes. So always this topology key will be something like this only. Always this topology key will be something like this only. But when this topology key comes into picture, when I am using pod affinity or pod anti-affinity, pod affinity or pod anti-affinity I am using, do I need to have this topology key also used? Yes. Now affinity and anti-affinity, and again preferred rules and required rules. You can use preferred rules again, pod affinity and anti-affinity. Guys, as I told multiple times, even though you are taking a CKA or CKAD exam, are you allowed to refer this official Kubernetes website while taking the exam also? Yes. But don't completely depend on this website, because do you have a time to read and understand and again do that solutioning? No. But if you are already practiced lot of times, you know the concepts, just to revise, will I able to quickly go through this website and see like this and get whatever I want to get, copy paste and modify as per your requirement? I can just copy paste this one and modify as per my requirement. That you can do, but don't completely depend on this website without practicing Kubernetes, without understanding what is Kubernetes and its architecture, what are the Kubernetes resources, what do you mean by deployment, what do you mean by service. Without knowing, without practicing this lot of times, if you directly go for a CK or CKAD, it will not work out. As I already told multiple times, how many times you can attempt, even though you failed for the first time, there is another chance. There is another chance. Second time you can appear. Maximum 2 attempts. Even though you fail to clear in first attempt, you will get another attempt. You can go and do it in a second attempt. But as I suggested multiple times, do you need to be practiced more? Do you need to have these Kubernetes concepts, Kubernetes commands on your fingertips? You need to be familiar with your Kubernetes concepts. You need to have your Kubernetes commands, this Kubernetes manifest how to write all these things on your fingertips. Like you should be able to quickly create a manifest, apply the manifest, troubleshoot, debug. That comes only when if you have put lot of effort understanding these classes, going through these classes, practicing multiple times. That comes by hard work. But don't think CK is too much complex. Lot of our students are able to crack within first attempt itself, but they have done lot of practice, lot of hard work. They have done lot of practice. They are very good at commands, manifest, writing the manifest, troubleshooting. Now, if you see node affinity we discussed, the way we have a node affinity, we have a pod affinity, pod anti-affinity. Does pod anti-affinity also support this required, ignore, preferred? Like again, if it is a preferred rule, again do I have a weights concept here? Even though I am using pod affinity or pod anti-affinity, if I am using weights concept along with topology, along with topology, along with topology keys. Now, what do you mean by the topology? The topology key can be allowed label key with following expectations, right? So some kind of a unique name, unique way identify your nodes. Now let me use pod affinity. Pod affinity concept. Now I will .yaml. Now let me modify this one. Now I want to use pod affinity. Guys, is it possible to use multiple pod affinity, node affinity together also, node selector and pod affinity together also? Yes, but that is very rare case. That is very rare case. You can use multiple scheduling constraints like pod affinity, node affinity together also. Now instead of node affinity, I am trying to use what? I am trying to use pod affinity now. I am trying to use pod affinity. Just to understand more clear, let's reduce the number of replicas. Otherwise, you will not understand clearly. I'll reduce the number of replicas to 1 so that you can clearly understand. Whether I use 3 replicas, whether I use 4 replicas, does that scheduling will work based on these rules? Whatever I am using here, whether it's 1, 2, 3, that doesn't matter. Based on the rules I am using here, it will work. Now affinity, I am saying pod affinity. Affinity, pod affinity. Instead of node affinity, I am using pod affinity. Now again, you can use required rules or ignore rules. I am using required rules now. I am using required rules. Required rules. Now in this required during scheduling, required during execution, label selectors, something different here. Label selectors. I am using something like this. Guys, if you have additional spaces, tabs, do you have a problem? Again, YML indentation. So I am using something like this. Required during scheduling, required during execution, label selector. In this label selector, I am using something like this. Match expressions. Match expressions. Then match expressions again, key. Key, operator, key. Whatever key you want to use. Key. This is another pod label key, another pod label key, operator. Operator, you can say whatever, in or not in. Values. Values is again multiple. Now let's say I'm giving this as an example. Now does this pod, whatever pod I am using here, does this pod will get scheduled wherever some pod which is already running in my cluster and that pod has a label called app and value as nginx? Is it going to be scheduled in that node wherever another pod with label called app and value as nginx is running in that cluster? Is it going to schedule in that node? Now, since I am using required rule, is it going to schedule this pod? If this pod, is it going to schedule this current pod? If already you don't have one application with this pod label and value, is it going to work? Is it going to schedule? No, because I am using required rule. Now here, as I already told, this pod affinity, anti-affinity works based on what? Based on pod labels. Based on the pod labels. Now topology key. Topology key. So I need to use the topology key, some unique way of identifying. The topology key is a sibling of your label selector. It's a sibling of your label selector. Now let me delete whatever I have so that you can easily understand. In the current namespace, I am deleting whatever I have so that you can easily understand. Now kubectl apply -f that Java web app pod affinity I am applying. Now if you see why that is in pending state, I just trying to create only one replica. Why that is in pending state? How to know? Can I describe that pod? Can I describe that pod and understand why? Describe, yes, was missing. Now what you can understand? 0 by 3 nodes are available. One node has a taint, our pod is not tolerating. The other 2 nodes did not match pod affinity rules, which means, do I have any pod already running in this cluster with that label? I am trying to show in all namespaces. Now, do I have any pod where my pod label is app value as Nginx in any namespace in this cluster? Do I have any pod where my app label, that pod label is app value as Nginx? No. Now, because of that, it is pending, because it is not matching with that pod affinity rules. Now, let me create a Nginx pod. Maybe that can be a pod or deployment, that doesn't matter here. That can be a pod or deployment, or that doesn't matter here. Now, wherever that Nginx pod gets scheduled, whether you are creating a pod, whether you are creating a deployment, replica set, that doesn't matter here. Now, I am trying to create one Nginx application. That can be a deployment with replicas 1, that can be a deployment with replicas 2, or that can be a pod, that doesn't matter. Now I am creating one Nginx pod. Metadata, name. I am creating one Nginx pod. But it no need to be a pod. Can I create this Nginx pod using any controller like replica set, deployment, daemon set, whatever it is? Yes. That doesn't matter here. Now this is my pod spec. I am creating it. Metadata is this. Now let's say labels. This is my pod labels. Now I am adding like this. Do you think this condition will satisfy? Do you think even though I schedule this pod, whatever other pod which is waiting because of pod affinity rule, do you think will it work? No. Value is matching, but key also should be matched. Key also should match, right? So app, Nginx. Now whatever. Now while scheduling this one, I'm not using any conditions. Does this pod can schedule in any node? Because while creating this pod, I am not using anything. I am not using any node affinity, node selector, whatever pod selector, that doesn't matter here. Now this pod gets scheduled in some node. Does other pod also get scheduled in the same node where this pod is going to be scheduled, because the other pod I'm using pod affinity rules. Yes, but a namespace, let me see, is it going to work at a namespace level? Now I'm trying to deploy this one in a different namespace, and let's see. Now the other pod, in which namespace I try to schedule, where I was using pod affinity default. Now let's see if I create this pod in test namespace, will it pick or not? This one I need to test. I thought of testing from so long. Now let me do this also now. I am trying to create this pod in a test namespace, but other pod is using this pod affinity rules. Now let's see. Now Nginx pod is there. Nginx pod is there with the label, app Nginx. In which namespace that pod is there? In which namespace that pod is there? Now there is a pod with this label app Nginx, which is there in test namespace. But if you see, still is this pod is scheduled? Is that pod is scheduled even though I have a pod? Even though I have a pod with that name label? No, because again this pod affinity, pod affinity rules, is it working within a namespace level? This pod affinity rules and anti affinity rules, is it working in a namespace level? Yes. But when it comes to node affinity, node selector, that doesn't matter. Namespace doesn't matter when I'm using node affinity or node selector. But when I'm using pod affinity, pod anti affinity, is it working at a namespace level? Even though I have a pod with that label app Nginx, this pod is still not scheduled. But let me do one thing. I am doubting one more thing. Let me delete that application and again deploy if that picks up. Let's see, I have one more doubt, one more scenario I want to test, because all the possible scenarios I will test now. I'm deleting that and again applying. But now the pod is there. That Nginx pod is there. Let's see if this picks up. Now I have that Nginx pod still. Pod is already running. Now let's see if I apply now again. I deleted that application and again deploying with that affinity rule. If this also doesn't pick up, then it will be a kind of a namespace level. Now if you see, it's kind of a namespace level only. Now again, is it in a pending state even though I have a pod? Now even though I have a pod that is running in this node 206 node, that Nginx pod is running, this is still pending, which means it is at a namespace level. Now let me delete that. Nginx pod. Now let me remove that namespace in that YML. Now let me remove that namespace in the YML. Now I have still that pod in pending state. This one where I'm using node affinity. Now I am creating now Nginx pod in the same namespace. I am creating now. Now this time the Nginx pod got scheduled in the same namespace. Now do you see this pod is getting created now? Is it came to running state? Now the moment pod is scheduled, this Nginx pod is scheduled to some node. It is scheduled to 206. Do you see the other pod also came to 206? It's already started running. Is everyone clear how pod affinity works? Pod affinity works based on the existing pods at a namespace level. Do I need to use the labels of the pods which are in the same namespace? Yes. Now what do you mean by anti-affinity? It's kind of a reverse. Now let me do this. it's kind of a reverse. Pod anti-affinity. Anti-affinity. Now it's kind of a reverse. Now is this pod gets scheduled wherever nginx pod is going to be scheduled. If I use anti-affinity rule instead of affinity rule, if I use anti-affinity rule, is it going to schedule in the same node where this pod is running? Is it going to run in the same node where this pod is running? No. So something like this. Pod anti-affinity. Remaining thing is same as is. Instead of pod affinity, we are using pod anti-affinity. Now again, it is a required rule. It is not a preferred rule, it is required rule. Now let me apply this. Let me delete existing one and apply so that you can easily understand. I deleted existing one. Now I am applying with anti-affinity rule. With anti-affinity rule, I am applying. Now if you see, do you see this nginx pod is running in this one 206? Is it scheduled in 206? No, 93. Now if I scale this one, if I scale this Java web app, maybe 2 replicas, 3 replicas also, is it going to schedule that a new pod in this node wherever this nginx is running? If I scale also, no. So this is anti-affinity. This is anti-affinity. Now one more important scenario which I wanted to discuss. Now I am trying to create a multiple replicas of my application. I am trying to create a multiple replicas of my application. Let's say I want to create 2 replicas of my application. I don't want this to be happen at any time. I don't want this to be happen at any time. How can I do that, guys? Same application pods, I don't want to run like this because I'll tell you one problem. I have 2 replicas. If both replicas are scheduled, are running in a same node, if something goes wrong with this node, does Kubernetes will shift the pods immediately to other nodes? Does Kubernetes will shift the pods immediately to other nodes? If something goes wrong with this node, whatever pods is running in this node, does Kubernetes will shift the pods? I mean to say, is it going to recreate the pods in another node immediately? No, it will wait for some time. Now let's say I am deploying this application with 2 replicas. Both replicas are running in this node, same node. Now that node went down. Now do you have a problem accessing that application within the cluster or outside the cluster? If that node went down, both replicas, I have only 2 replicas. If both replicas are running in same node, do you have a problem accessing that application for some time internally or externally? Now how to avoid this situation? I don't want these 2 replicas running together. Same application parts will never schedule together. What concept I can use? Can I use pod anti-affinity on the same labels on the same application itself? Can I use pod anti-affinity? On the same application labels itself, can I use pod anti-affinity? So does this will happen anytime? If I use pod anti-affinity on the same pod labels also, it will work like this. It will never run together. So can I use this one to avoid that type of situation also? Yes. So let me show that. Now I am trying to use pod anti-affinity rules, but on the same application, like same labels. Can I use multiple also, guys? You can see this one as an array, So can I use this multiple times also, this key value multiple times also? Yes. Now let's say app Java web app. Now even though I create 2 replicas, 3 replicas, is it going to run together anytime? I am creating 2 replicas. Let me apply Java web app pod anti-affinity. Now I am using on same thing. Now do you see one is running in 93, another one is in pending state because of no resources available. To understand better, delete and apply. To understand better, delete that application and apply so that you can easily understand. Unless until you are good at troubleshooting, you cannot understand. So let me delete and let's deploy now. Let's deploy now. Now if you see, now do you see one is scheduled in 93, another one is scheduled in 206. Now if I try to scale, if I try to scale also, unless until I have some additional nodes, even though I have enough CPU, enough memory in this node, on this node, does my pod get scheduled to these nodes? Even though I have enough CPU, enough memory available in this node or this node, does third pod get scheduled to this node or this node? Because of anti-affinity rules, I am using pod anti-affinity rules. Even though I try to create 3 replicas, let me apply. Now if you see why this is in pending state, the third replica, is it because of no resources? It could be or it might not be. It could be or it might not be. Let me show you. kubectl describe pod. Now why it is? Because node, that pod affinity, that pod anti-affinity rules are not satisfied. Why it is not considering master? Why it is not considering master? In the master node, I don't have that pod because master node has a taint. Now, if I tolerate that along with my pod affinity rules, pod anti-affinity rules, if I tolerate that one also, taints, then is it going to schedule that a third replica in the master? Because in the master as of now, this is not running. In the master as of now, this is not running. If I tolerate the taints here, then does that third replica get scheduled in the master? Because if I tolerate that one, yes, that is how it works. Is everyone clear, guys? Whatever we discussed so far, what do you mean by node selector? What do you mean by node affinity? Soft rules, hard rules, pod affinity, pod anti-affinity. Then I will discuss about these taints tolerations in the next class. The next class is on Thursday, guys. Tomorrow I may not able to take the class. Thursday I am taking the class. Tomorrow I have to attend one puja because I am constructing one farmhouse. Tomorrow I need to do the foundation, so I have to attend some puja. So I'll not be taking class tomorrow because of some puja in my farmhouse from my farmland. So I'll take a class on Thursday. Tomorrow no class. Try to practice whatever has been discussed. I'll continue on Thursday. I mean to say 12th. So 11th, no class. Try to practice whatever has been discussed. I'll continue on Thursday. Thank you, guys. We'll see you on Thursday.